We're going to finish up with one more example from like what we were doing yesterday. So if you'll remember on your calculator, I showed you how you can go from degrees, minutes, and seconds
I couldn't find that when you were explaining.
into a decimal number. Okay, so let's look at one of those just to make sure we know how to do it. Okay, so like if I want to do this one, 75 degrees, put in 75, hit that button. Now I click 36, click that button, and then click 50, click that button, click equals, click equals, yeah. And then click S to D, click it again. And that's what it is a decimal number. 75.6138 with the 8 repeating.
Where's that table?
That's right above it.
Oh, wait, it's the.
Anybody else need help doing it in this direction? From degrees, minutes, and seconds to a decimal? Everybody's got that? Now let's go in the other direction. Let's go from a decimal number to degrees, minutes, and seconds. So if I was going to, let's do this one. 42.457. In my calculator, I'm going to put in 42.457. So everybody enter this in and click equals. And then click your degree button. The degrees, minutes, and seconds. And it'll convert it for you. Everybody good with that? Okay. So that wraps up Chapter 5, Section 1, Part 1. Now we're going to go into Part 2. Okay, so we talked a little bit yesterday about degrees and why are there 360 degrees in a circle, and we did not have a very good answer. And then I said, well, what if there was a different way to measure a circle besides using degrees? So we're going to talk about radian measures of angles. Do you guys remember doing radians in geometry? Don't remember. Okay. You did them, but that's okay. Unit circle is a circle with a radius of 1 and its center at the origin. So almost everything we're going to do in trig revolves around a unit circle. So let's make sure we know what a unit circle is. So what does it mean if it has a radius of 1? Well, that means the distance from the center, which it tells me is at the origin, to any point on the circle has a distance of 1. Right, so that's a radius of 1. If I measured it to here, that's a radius of 1. Anywhere from the center to an edge, a point on the circle, gives a radius of 1. So a radian measure of an angle in standard position is simply the length of its intercepted arc on the unit circle. So maybe one of these fits. If they don't, I can shrink it. Oh man, it's still got a lot to it. Okay, that's pretty close. Okay, so this is the length of the radius. What it's telling me a radian is if I take this radius and go along the intercepted arc, which means along the actual outside of the circle, then this distance that I travel from here to here, that is 1 radian. And so we would say that the distance that we rotated is also 1 radian. Okay, so how many radians are there in a circle? Well, let's look and see. That's 1 radian. If I go from here to here, it's going to put me at another radian. And then from there to there is another radian. So in half a circle, there are a little bit more than 3 radians, right? That would be 1, 2, 3. Anybody have a guess of how many radians are in half a circle? It's a number that's a little bit more than 3. Pi. There are pi radians in a circle, in half a circle. So we would say pi radians is equal to 180 degrees. Because there are pi of those rotations around. So it's just more than 3. It's crazy. It's an irrational number. It's amazing. Pi is just an amazing number. So what would that translate to if I went all the way around the circle? So 360 degrees would be how many radians? Well, we would go pi and we go pi again. So it would be 2 pi radians. So do y'all remember seeing either one of these conversion factors in geometry? When you converted from degrees to radians and radians to...
I don't think we really talked about radians. Yeah, this
Okay.
does not sound anything like that.
Okay. Maybe when we start doing the math, you might remember that part. But this, I know you did it, I promise. But this is another way to measure a circle. So the reason that radians are so cool is because it doesn't matter the radius of the circle. You see here, that time I used a radius that was this distance. But if I make a bigger circle, so let me just draw one. I used to have a circle drawer. I left it on my fridge at my house. I meant to bring it today. Come on, Cody. You can do this.
Was that part of the language? That's one.
It is. I cut it yesterday.
Whose was it?
I don't know. It was left in here. I mean, it was like left in the closet. I don't know if it was Miss Shankle's.
Oh.
It's not like some student left it and I cut it up.
That's
For
what I
fun.
thought you meant.
Okay, so this is my kind of attempt at drawing a circle. It was this radius, okay, all the way around. So we'll see here, in this circle, it has 1 radian, two radians. Oh, man. Yeah, no, I didn't do a very good job. But you see, oh, that's the human error. You see how it's real close to 3 radians? It's the exact same, okay? In every one. Trust me. Okay? No matter what radius you choose, the radian will adjust with it. So there's always exactly pi radians in half a circle, no matter the circle size. I could make an even bigger circle, but that would be an even bigger mess, so forget that. Okay. Let's read here. 1 radian, abbreviated 1 RAD, is the real number 1 without any dimensions. So the other reason that radians are so nice is because, like degrees, we can't do regular math with them. Like I can't just multiply some number by degrees and make it make any sense. because the degrees has a unit with it. However, radians don't have any dimensions, which means we don't really have to write this unit. The unit is dimensionless, okay? It's not, we can do regular math stuff with radians. We can multiply it, we can add it. It works just like regular numbers. So, definition of a radian measure. To find the radian measure of an angle alpha in standard position, find the length of the intercepted arc on the unit circle. If the rotation is counterclockwise, the radian measure is the length of the arc. If the rotation is clockwise, the radian measure is the opposite of the length of the arc, which means it's negative. So that's really a bunch of mumbo jumbo. It means whatever I measure, if I want to find the angle that I rotated, just find out how far along that circle I was, that they're the same thing. The angle measure in radians and the distance traveled in radians always match up. Radian measure is called a directed length because it is positive or negative depending on the direction of rotation. So just like we talked about yesterday, rotating in degrees, if I go counterclockwise it's positive, if I go clockwise it's negative. We know the circumference of a circle with radius r is, so do we know what the formula for circumference is?
Oh,
Come on, Cornerstone. Come on, Cornerstone.
circumference equals pi r squared.
No, wrong.
2 pi.
That's correct. Who said that? Okay. Yeah.
I looked it up the other day.
Oh. Do we know what circumference means? Like, what is circumference? Yeah, so how would you explain that, Moose?
The perimeter of the circle.
Yes, it's the perimeter. You know when we have anything with sides, to find the perimeter, we add up all the sides. Because that's the distance around the outside. Well, circumference is just the distance around the outside, so we would add up all the sides. Problem? There are no sides. Okay, so we have to find a different way to find the distance around the outside.
Well, it's 2 pi radians.
2 pi times the radius. Yes. And how did we come up with that? Do you see where that comes from? The radius is what? The distance around the outside of a circle. And how many times do we go around the circle? 2 pi times. Right? That's the whole conversion factor. That's where this comes from. 2 pi r, we take this radius and multiply it by 2 pi. Because that's how many times this would fit around the circle. So the circumference of the unit circle is, so what's the unit circle? What's the radius? The unit circle is a circle with a radius of 1. So we would plug in 1 for r, and we would get the circumference of the unit circle is just 2 pi. Well, let me get the rest of that. That was a bad place to cut off.
So is trig just like geometry?
Trig is a study of right triangles. Trigonometry. Triangle. It's all about right triangles.
So it's not gonna be like algebra and that kind of stuff?
Nope. It's going to be completely different. It's its own branch. So whether if you hated what I did before Christmas, you may love this, or you may hate this too. It's completely different. It's like we're starting over from scratch.
So is our semester test gonna have both on it?
No.
Yeah, so everything
So it's gonna be just,
You had your semester test on pre-cal, on algebra. Pre-cal, the first semester is basically algebra 3. They used to call it algebra 3, but then they added trigonometry onto it, so you didn't get it in depth in algebra 3 as your parents or grandparents did. So that's called pre-cal.
maybe I like this math that
If an angle rotates a full circle, we know it is 360 degrees, and the length of the intercepted arc is 2 pi. So we can express this relationship as 360 degrees equals 2 pi, or 180 degrees equals pi. You get that just by dividing both sides by 2. Right, I kind of ruined that punchline already. Okay, so here at the bottom, it says, conversion from degrees to radians or radians to degrees is based on. So, in geometry, when you first learn about this, they normally teach formulas to remember. I'm converting from degrees to radians, then I need to divide by 180. I don't remember. I hate the formulas. I don't know if I've already told you, I hate formulas. I don't like to memorize formulas. But I know I can have a conversion factor, a conversion rate. So what we do is we set up pi radians over 180 degrees. Or you can do it the other way. It really doesn't matter. You can do 180 degrees over pi radians. You just have to make sure when we set it up that we match our units. And we'll see what that looks like in just a second when we do those. But what is this number that I'm setting up? It's just a fraction. What did we just establish? We said 180 degrees is the same thing as pi. So if I took 180 degrees and divided it by pi radians, what is this number?
Half a circle.
It is half a circle, but what is that number that I put in a fraction? Okay? What about this? What if I took the number 0.5 and divided it by a half?
1.
Because these two things are the same. They're written differently, they're in different forms, but it's the same measure. Same idea here. This is just the number 1. So when we multiply something by this, we're not changing the number, we're changing its form. Because we're just multiplying by 1. And we're always allowed to multiply by 1. Okay, see what's next. Okay, so first we get 270 degrees. And we want to convert to radians. So when we're converting from degrees to radians, I would write 270 degrees. Now I want my degrees to cancel out because I want to go from degrees to radians. So the way we make sure we cancel degrees is we put degrees in the denominator. Because degrees in the numerator and degrees in the denominator will cancel. So my conversion factor is 180 degrees over pi radians. So that's what I'm talking about when I say I don't know a formula. I can't remember the formula, but I know to set it up like this. I get my degrees, one on top, one on bottom, so they cancel. And now then my only unit that's left is radians. So when we multiply this out, 270 times pi is 270 pi over 180. Again, the degrees cancel. And that's just 27 over 18, which is 3 pi over 2. Or we could write it as 3 over 2 times pi. I put pi in the numerator most of the time. But those are equivalent.
So do we just get rid of the radian thing?
You can leave it. I mean, that's the good thing about radians is they are unitless. So we can call it 3 pi over 2 radians, or we can just call it 3 pi over 2. It means the exact same thing. Okay, so then for the next one. So every one of these is going to be the same then. If I've got it in degrees, and I want to convert it into radians, I mismatch my units. Degrees were on the numerator, so now I put degrees in the denominator, which means radians is in the numerator. The degrees will cancel, so now I've got negative 23.6 pi over 180. So if you put in your calculator 23.6 over 180, it should give you a fraction number.
59 over 450.
So that would be 59 pi over 440. Is that right? 450? 450?
Yes. How does it get bigger?
And that would be negative. It's not bigger.
Well, Why did the numbers get bigger?
Because I had to get rid of the decimal. So to get rid of a decimal, I multiplied by, see, I was thinking I had to multiply by 5. The 26 times 5 would be 30, but there must have been something else that would reduce by, I guess, maybe 2.5.
Why did you have to get rid of this?
Because we don't put decimals in fractions.
Oh, this one's our
Yes, but we don't, in our fraction, have decimals. Ever.
Like,
I know I did it just a second ago, but that was to prove a point. Right, about a half and 0.5.
what about if there's a fraction and a part?
We don't do that? It simplifies. Your calculator will fix them all when they're numbers. It'll fix it where there's no. Like if I had a fraction, if I had 5 over a half, what I do, I make that 5 over 1 divided by a half. So that's 5 over 1 times the reciprocal. Always fix it. Don't ever leave a fraction in a fraction. And the last one, 210, which is going to give us 7 pi over 12, obviously. So this is 210. We're going to multiply by pi radians over 180 degrees. The degrees cancel. No, I messed up. Dang it. Okay, so that would give me 210 pi over 180, which reduces to be 7 pi over 6. Man, my trig is rusty.
Are we gonna do this both back and before they were?
Yes. That's all section 1.
You mean to tell me the one time I understand something?
Yeah, this is getting freaky flashbacks. I think I
It's the only thing I've got to do.
Have it going through a number and all of that.
Okay, now let's go in the other direction. I have 7 pi over 6. So I'm going to write it like a fraction. And now I want to convert from radians to degrees. So now I need degrees in the end. So I'm going to put my degrees in the numerator. I'm going to put my radians in the denominator. Okay, so sometimes this happens with radians and sometimes it doesn't. So don't act like it's a sin if it doesn't happen. But when I had a pi to start with, and then I multiply by pi radians, those pi's are going to cancel in the numerator and denominator. So then I have 7 times 180 divided by 6, which is 210. Okay, the next one is 12.3 radians. So this one doesn't have a pi in it. So when I do my conversion, there's going to be a pi left in the denominator, which is ugly, right? This probably happens 5 to 10% of the time where you have the pi left. We just don't like working with those numbers, but it does happen, it can happen. So don't think that you've messed up if it does. So I've got 180 degrees over pi radians. So now the pi has nowhere to cancel with, so I'm just multiplying straight across. 12.3 times 180, so that's 1800 plus 360 plus 2214. So that'd be 2,214 degrees.
I thought you said there'd be a pile up there.
Yeah.
There is. Over pi. Thank you.
And we can still leave the radians there.
No.
No?
No.
I
I mean, I don't guess it's wrong, but we want that answer in degrees. So it would be confusing if you had degrees and radians in it. The radians don't matter, but we don't want to say them. trying to think of an example. Okay, and then the last one, I've got 5 pi over 3 radians. I want this to be in degrees, so I put degrees in the numerator. My pi's cancel. That leaves me with 5 times 180 divided by 3. That's 300. Okay, so what we're going to do now is we're going to look at some common angles that we're going to use in trig. This is the beginnings of what people call a unit circle. And a lot of math teachers, when they teach trig, they teach you to memorize this unit circle. I told you I hate memorizing, but that's an option that you'll have, is to memorize this, and it'll get more in depth as we go. But I'm not going to make you memorize it because I don't have it memorized. I discover it every time I need it because that's just the way my brain works. So again, think about this as being on the XY axis. This is my initial side that's measured at 0 degrees. This is where I'm starting. And then we do our rotations around. So it's going to be 30, 45, 60. And then if I form a right angle, that's 90 degrees. And then we add another 30 degrees. That's 120, 135, 150, and 180. Then add 30 degrees to 10, 225, 240, 270. And then 310, 325, no, 300. Like I said, those numbers don't make sense. 300, 315, 330. And then when I get all the way back to where I started, that is also 360 degrees. What are you asking? You know about how this angle looks smaller than this one? From here to here's 30. From here to here's 45. You with me? So like, I'm not telling you that this measures 45 degrees. That is 15. It's between 30 and 45. We're always going back to our initial side to find how much we rotated. So from here to here is 30, there to there 45, there to there's 60, there to there is 90. Always back to the initial and then ending at that terminal side.
Why did they do it like 30 and then like 2 15 and then 30? I'll just make it all even.
Because we've got 2 special right triangles that we're going to use to find these. We're fixing to do trig without a calculator. Like when we start doing sine, cosine, tangent, you can't use a calculator. Because I'm making you do that. That's what we're learning. We're learning how to do sine, cosine, and tangent without a calculator. It's easy.
Well, I guess that's
It's
okay,
easy.
because I don't even remember how to do it on the calculator. I don't either.
Okay?
I used to have all the formulas written.
We'll do some of the harder ones on the calculator, but when we do tests, I make you not have your calculator. I make you use. I used to have 4 function calculators. I don't know what I'll do now since COVID. I may make you all go buy your own. They're just like $1. I'll give you all $1 to buy it so you can have it. Okay. Now we're going to also write the radian measures. So. Again, you could go through the process of converting every time, or the more often that you work with this, you'll see the pattern and you can maybe memorize it. So if I rotate nowhere, that's 0 radians. 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians. 60 degrees is pi over 3 radians. 90 degrees is pi over 2. 120 degrees is 2 pi over 3. This one would be 3 pi over 4. This one is 5 pi over 6. And this is pi. And we'll talk more about how maybe you can remember them as we'll go back. 210 is 7 pi over 6. 225 is 5 pi over 4. 240 is 4 pi over 3. 270 is 3 pi over 2. 300 is 5 pi over 3. 315 is 7 pi over 4. 330 is 11 pi over 6. And when I go all the way back around, it's 2 pi. So like for me, when I'm remembering the radian measure, when I'm going in 30 degrees, I always think about it being divided into 6 pieces. So you know how you're talking about you want it to be evenly divided? Well, in my head, I imagine this line's not here. Okay? So now I've got the top half of my circle divided into 6 pieces. You see that? They're all evenly spaced. So this would be, when I rotate, 1/6 of the circle, 2/6 of the circle, 3/6 of the circle, 4/6 of the circle, 5/6 of the half a circle, and then that's a total, 6 out of 6. Right? You see how it's coming around? And then look at how that coordinates with these. So when I rotate 1/6 of the way, it's pi over 6. When I rotate 2/6 of the way, 2/6 is 1/3. When I rotate 3/6 of the way, it's a half. 4/6 is 2/3. 5/6, and then 6/6 is a whole 1 rotation for pi. And then that's the way I think about it all the way through. So now then, when I rotate here, I know I went 1 whole way. So 6 out of 6, and then I'm going to add 1 more. 7/6, 8/6, 9/6, 10/6, 11/6, 12/6, or 2. That's the way I think about my 30s and 60s. 30, 60, 90, 120, 150, 180. You don't have to do it that way. Like I said, you can memorize. You could convert every time. I'm just letting you know how I think about it, so when I do it kind of quickly, that's how I've done it. And the 45s are easier because you're dividing it into 4s. So now imagine that the 30-degree rotations aren't there. So if you take out this one, and this one, and this one, and this one, now I've got 1/4 of the pizza, or 1/4 of, this is a little confusing. There's 1/4. Yeah, 1/4 of the half circle. Here's 1/4. There's 1/4. There's 1/4. So I'm just going 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. All the way around. And like I said, again, that's not like required that you know it that way. That's just the way I'm letting you know how I think about it. Okay, so we're finding 2 positive and 2 negative coterminal angles. So just to review, a coterminal angle is an angle that has the same initial and terminal sides. We want to find 2 positive and 2 negative. Okay? So what we did yesterday is we added 360 degrees and we subtracted 360 degrees until we found everything that we needed. Well, now that it's in radians, instead of 360 degrees, I'm going to add 2 pi. Because 2 pi is a full revolution instead of 360 degrees, because we're not in degrees. So when I look at 4 pi over 5, then I want to add 2 pi to that. So I think your calculator would probably do it. But if you had to add 2 pi to a fraction, you've got to get a common denominator. So my common denominator would be 5. So 2 pi is the same thing as 10 pi over 5. And then when I add that, I keep the denominator the same, combine the numerators. 4 pi plus 10 pi is 14 pi. So 14 pi over 5 would be coterminal. Then I would add 10 pi over 5 to that. So that would give me 24 pi over 5 would be coterminal. So those are my 2 positive coterminal angles. Now I need to find the negative ones. So we find the negative ones by subtracting 360 degrees. So we're going to be subtracting 2 pi. So when I go 4 pi over 5 minus 2 pi, I'm thinking about subtracting 10 pi over 5. That's going to give me negative 6 pi over 5. And then when I subtract 10 pi over 5 again, that's negative 16 pi over 5. Everybody with me on how I did that? Adding, subtracting 2 pi. So in that time, 2 pi took the form of 10 pi over 5. Every time we do these, 2 pi is going to look different depending on what my denominator is. So in the next one, I have a denominator of 4. So if I add 2 pi, think about giving that a denominator of 4. So I'd multiply by 4 on top and bottom. So that would give me 8 pi over 4 is the same thing as 2 pi. So now I'm going to add 8 pi over 4. When I do that, that gives me negative 3 pi over 4. So that is actually another negative coterminal angle. Again, I'm looking for the positive one, so I need to add 8 pi over 4 again. So if I add 8 pi over 4, that's going to give me 5 pi over 4. So that's a coterminal angle. And then I would add 8 pi over 4 again, which gives me 13 pi over 4, which is a coterminal angle. So right now I've got 1 negative and 2 positive coterminal angles. So I need to find another negative one. So I'm going to go back to my original, negative 11 pi over 4. I'm going to subtract 2 pi, which is 8 pi over 4, to give me negative 19 pi over 4. So those are my 4 coterminal angles. Negative 19 pi over 4, negative 3 pi over 4, 5 pi over 4, 13 pi over 4. Now the next one, we're going to name what quadrant the angle is in. So A is 11 pi over 6. So again, you could go look at that circle. You could do conversions. Like you could turn that into degrees and then figure out what angle, what quadrant that's in based on its degree measure. Okay, but the more you do these, you should become more and more comfortable with radians. So when I look at that, I see 11 pi over 6, and I'm trying to go to the nearest 90-degree rotation. So I know I've got pi over 2, pi, 3 pi over 2, and 2 pi. 11 pi over 6 is really close to 2 pi because 2 pi would be 12 pi over 6. Does everybody follow my line of thought with my fraction? 12 over 6 is 2. So this is really close to 2 pi, but it's not quite to 2 pi yet. So it's almost a full revolution, but not quite. That means I'm in the fourth quadrant. Like I said, if you went through all the trouble of converting it, you should get this as a 330-degree angle. And then you could say 330 degrees is between 270 and 360. So that puts me in the fourth quadrant. Now the next one. So when it's radians like this, negative rotation means I'm rotating clockwise. That one is really negative. Like that's over one full revolution. Because 8 pi over 4 would be a full revolution. Right? Yes. So what I would do is I would actually find coterminal angles for this one. Because I'll mess it up in my head if I don't. So I would add 8 pi over 4. And I would add 8 pi over 4 again. So that means I'm adding 16 pi over 4. Which is 2 pi and then 2 pi again. Is everybody with me? I added 2 pi and I'm adding 2 pi again. When I add 16 pi over 4, that's going to give me pi over 4. I know pi over 4 puts me in the first quadrant. That's a 45-degree rotation from its initial to terminal side. Again, I can't stress this enough. The way I do this is not the only way to do it. I hope I've shown you all the tools. You can figure out your own preferred method of converting them. I'm just showing you how I do it, and this is obviously how I do it without a calculator, right? Because I don't have one. If you have a calculator, you can do more steps and probably do it just as quick as I do. So in my head, negative 15 pi over 4, so I wanted to add 2 pi. So when I add 2 pi, common denominator, that's 8 pi over 4.
Why do you want to add 2 pi?
Because I don't like negative radians that go more than one full revolution. Because I lose that in my head when I try to rotate it. Like, if I was looking at 400 degrees, I can do the 360 and know there's 40 left over. Because in my head, that's not a problem. But when I start trying to keep fractions in my head, I start getting confused with where I rotated to. So I do not like rotating more than one time around in radians. It messes with my head. So I was finding a coterminal angle that has the same side. Like we've been doing, finding coterminals. So I could add 2 pi. Well, if I added 2 pi to a fraction, I need to get a common denominator. So just like we did before, 2 pi over 1 is the same thing as 8 pi over 4. So if I add 8 pi over 4, that's still going to be negative, so I just want to add 8 pi over 4 again. So 8 pi over 4 plus 8 pi over 4 is 16 pi over 4. And I saw that was going to work really nicely because 16 with negative 15, that's going to put me right there at a value of pi over 4, which I know is in the first quadrant. And you don't have to do it that way, right? You could just put in your calculator and put plus 2 pi, and get there, and then figure it out.
I did it like way different.
How'd you think about it?
I just put negative 15 over 4 into my calculator because I knew that there were 4 sections in the half circle, and I got negative 3.75. So I have 3 of the half circles. I go around 1.5 pounds, and then I 0.75 left, so I get right on the 45 in the first one.
So that's kind of, yeah, that's fine. Again, several different ways to do this. And everybody doesn't think about math the same way, and that's fine. You don't have to do it that way. Now, the next two, find the measure in radians of the least positive angle that is coterminal. So this is like what we did yesterday. We want it to be positive, but we want the smallest possible coterminal angle. So if it's negative, that means, If it's positive, like this first one, that means I need to subtract 2 pi until it becomes negative. And when it becomes negative, I know I've went too far. If it's negative, then I'm going to add 2 pi until I finally get it to be positive. Okay? So, in this example, if I'm subtracting 2 pi, I want 2 pi to be over 3. So I would multiply by 3. So that's the same thing as 6 pi over 3 is 2 pi. So I would subtract 6 pi over 3. That would give me 10 pi over 3. I would subtract 6 pi over 3. That would give me 4 pi over 3. And if I subtracted 6 pi over 3 again, it would be negative. Well, that's not what I'm looking for. I'm looking for the least positive coterminal angle. So that would be my answer, 4 pi over 3. The next one is negative, so I want to make it positive by adding. So same idea, I'm going to take 2 pi, and I want to give it a denominator of 12. So I multiply by 12 on top and bottom, so that's 24 pi over 12. So if I did negative 7 plus 24, that would give me 17 pi over 12. I've made it positive. So that's the least positive coterminal angle. Would be 17 pi over 12.
Where did you get 2 pi over?
2 pi, that's the full revolution. That's how we did those problems yesterday, was adding 360 degrees. So when we're in radians, we want to add 2 pi every time to find our other coterminal angles. And I just put it over 1 so it would be a fraction, so I could find the common denominator.